Hello everyone and welcome back to the channel. In distributed systems, networks are inherently unreliable and services can fail. Because of this, retries are a crucial part of building robust applications. But what happens if you retry an operation that isn't designed to be retried safely? Imagine accidentally charging a customer twice or creating duplicate orders. This is the core problem that idempotency solves. In system design interviews, understanding and applying idempotency is a clear sign you can design truly reliable and fault-tolerant systems. Today, we are diving into what idempotency is and how you can achieve it. Okay, so let's set the stage. Networks are inherently unreliable, as we said before. Requests can time out, packets can be dropped, or responses might get lost. Because of this, clients and messaging systems must implement a retry logic. If a server sends a request and doesn't get a timely response, it often assumes the request failed and retries again. The danger of this one, the critical danger comes if the original request actually succeeded on the server, but the response was lost. When the client retries again, the server will execute the operation again. If the operation isn't idempotent, you get unintended side effects like transferring money twice or sending duplicate emails. This is a common source of bug and financial losses in distributed systems. This sets up an absolute necessary for idempotency. Before we go to the next section, let's give it a small example. Let's say that we have an e-commerce and we have a client here. And this is our server, okay? So our client likes our products. He wants to buy a product. He select the product, he put it to the cart, and right now our client is in the payment page and he tries to pay for this product. So the order will be approved. So the client will click on pay, one click, and this sends a request to our server. And our server actually take the money amount from our customer and try to send the message back or like a response back that, yeah, we got your order, but our server fails to send this message. So the client here will assume that he or she didn't pay for the product. So they will try to send another request. So our server will make another payment. So basically we charged our customer twice and instead of only once. It's really a huge problem. Okay, so right now understand the problem. We need to understand what exactly is idempotency. An operation is idempotent if executing it multiple times produces the same result as executing it just once. The key here is same result, not necessarily same state. The effect on the system after one execution is identical to the effect after 5, 10, or 100 executions. Think of a simple analogy. Pressing a light switch to the on position, if the light is off, it turns on. If you keep pressing on while the light switch is already on, the light will remain on. The result is the same regardless of how many times you perform the turn on operation. This is an idempotent action. If you had an operation that would not be idempotent, as repeating it would be change the state each time. Okay. Let's talk about the HTTP protocols, the HTTP methods that are idempotent. After that, we talk about the HTTP methods that are not idempotent. So we have get, put, delete. Get always idempotent. It's retrieving the same resource multiple times. Will yields in the same results. We have put is idempotent, like when you put a resource, you are replacing the entire resource at a specific URL with the provided payload. Repeating this sets, the resource will be the same state. It will never change. The delete is idempotent because deleting a resource multiple times had the same effect as deleting it one time. Also, there is a head of options trace. All of these are idempotent. Okay, what are the methods that are not idempotent. First, this is the biggest one, which is post. This one typically not idempotent, because if you post to create a new resource, repeating that post request will usually create multiple new distinct orders, so it's not idempotent. And here we have patch. These methods can be idempotent or not, depending on how it's designed. If patch applies the same specific partial update repeatedly, which is, for example, increment user score by 5, it's a non-idempotent. But if it applies a specific atomic change based on a known state, like set user state to active, for example, it can be idempotent. And yeah, a quick hack. I would say a lot of interviewers love to ask about patch, so pay attention to this one. Okay. So let's talk about how to achieve idempotency. And the first one is idempotency key, and I highly recommend you to just focus on this section, because this is the most important section in the video. The concept of idempotency key is the client generates a unique immutable idempotency key and sends it with every critical request. This is a key uniquely identifies a specific attempt to perform an operation. So if you understand how it works in four steps. The first step number one, if it first checks a fast storage like Redis or a cache or a detected idempotency table in the database, to see if this idempotency key has been seen before. So when we have the client here and we have the server, the client will add the idempotency key to each request it sends, post request or patched requests. So the server will look at the idempotency key and it will try to have a look at like a fast storage like Redis or a cache for this idempotency key. If this key is found and the associated operation has already been successful or completed, the server immediately returns the cached result of the previous successful execution without re-executing the business logic. If the key is not found but the operation is still pending or failed, the server might return an error or perhaps wait and retry later. If the key is not found, the server will execute the operation, persist the idempotency key along with the operation status and result, which will be like a new order ID or payment receipt or whatever it will be, and then returns the results to the client. Okay. So let's talk about next, which is why idempotency matters that much. Idempotency is a paramount for distributed system and for any reliable distributed system. First, it has a robust retries, like it allows clients and message queues to safely retry operation without fear of unintended side effects, making your system more resilient to transient failures. Number two, message queue reliability ensures that consumers of message queues can safely reprocess message if needed, even if the queue delivers message multiple times. Number three, user experience prevents frustrating and potentially costly issues like double changes or duplicate notifications for end users. Lastly, simpler error handling reduces the complexity of handling partial failures, as you don't have to write elaborate companion logic for potential duplicates, for example. Okay. How to discuss this concept in your systems design interviews. So in systems design interview, bringing up idempotency when discussing any transactions like operations, it's critical changes, or whenever retries are involved, you need to explain the idempotency key strategy as the gold standard. It demonstrates a sophisticated understanding of building truly resilient real-world systems. Also, you need to think about some specific systems. Like if you are designing an event-driven system, you need to expect that your interviewer will talk about idempotency because it's a big part. Yeah, I would say that's it for this video. Let me just check if I have forgot something. Oh wait, I guess I forgot something. I only talked about this. I didn't talk about preconditions, unique conditions, and state tracking. Sorry for that. I'll talk about it right now. So preconditions, it's here for update operations. You can use optimistic locking or version numbers for examples. Update records set value equals a new where ID, for example, equals X, something like that. We have here unique constraints. This one for insert operations. If your business logic has a natural unique identifier, you can enforce a unique constraints at the database level. If a duplicate insert request arrives with the same order reference ID, the database will automatically reject it. Also, you can have like a state tracking, like explicitly track the state of a long-running process in your database before processing a new event. Check if the desired state has already been reached for a specific transaction. If so, simply return the state without re-executing. And that's it. So that's it for this video, and see you in the future.